Well, basically, let's first define what does the word like congruent mean. So when we say that like two figures are like congruent, that essentially means that like the two figures are like the same. So like if I have like this like weird shape or something, and um let's say I have like this weird shape as well, like clearly like these two shapes like look the same. So like if two figures are like have the same shape, they have like the same size, then we say like they're congruent. So like this would be like an example of like two congruent like pentagons, for example. Another example of a pair of congruent shapes would be like, for example, maybe this quadrilateral and like this quadrilateral. These two are congruent because they're both like they both have the same side lengths. Essentially, you can think of congruence as like a fancy word of saying that two things are like identical. But note that like you can say things are congruent. They don't have to be in the same orientation. For example, I could like rotate like this quadrilateral like 90 degrees or something. The two shapes would still be considered congruent as long as like all the side lengths and like the size and the shape match up. Then we say like the two figures are congruent. But most of the time in math competitions, we will be focusing on congruent triangles because most of the time you won't be seeing like congruent quadrilaterals or pentagons very much. Most of the time it'll be about congruent triangles. So when we say that two triangles are congruent, using the definition of congruent, that just means that the two triangles have like the same shape and size. So like, for example, a triangle that looks like this and a triangle that looks like this, for example, we say that they're congruent since they're like identical in size and shape. So we will now be talking about like 4 different ways that we can use to identify whether or not like two triangles are congruent. So the 4 types of congruence are called SSS congruence, SAS congruence, ASA, and HL. So we'll go through each of these more in depth now. So let's first start out with SSS similarity, or SSS congruence, I mean. So what SSS congruence stands for is it just stands for side, side, side. So what this means is like if you have two triangles and you know like all 3 of the sides are the same, like for example, let's say you know this side has length 3 or something, and let's say another side has length like 5, and like maybe this side has length like 6 or something. And let's say in the other triangle, you also know that the side lengths are 3, 5, and 6. Then we can say by side, side, side similarity, or side, side, side congruence, so SSS congruence, that we can say that these two triangles are congruent because they have all 3 of the side lengths the same. So that's basically SSS congruence. That's probably the most intuitive type of congruence. The second most common like way to tell if two triangles are congruent is called SAS congruence. So SAS congruence just stands for side angle side. Side angle side. So side angle side congruence just means that if you have two triangles, let's say you don't know all 3 of the side lengths, but you know one of the angles. So let's say you have, again, like your 2 triangles, and let's say you know, let's say this length or something is like 4, and let's say this other length here is like 7 or something. And let's say you know this like angle in between them is like, 60 degrees or something. I don't know. And let's say in the other triangle, you also know that the triangle has a side length of 4 and has a side length of 7, and the angle between it is 60 degrees. Then we can conclude that these two triangles are congruent by SAS congruence. Note that it is like important that the angle is between the two sides. It turns out like if you knew the 60-degree angle was like not there, but like instead like maybe the 60-degree angle was over here, it turns out you cannot conclude that the two triangles are congruent. So just know that like only SAS congruence works. The angle has to be between the two sides. And it turns out like if the angle's not between the two sides, there are actually 2 possible triangles, which is why SSA congruence doesn't work, but SAS congruence works. So that's how SAS congruence works. The third type of congruence is called ASA. And ASA congruence, like you can probably guess, it stands for angle side angle. So if you have like two triangles again, let's like draw the two triangles like this or something. And let's say we knew two of the angles. Let's say we didn't know much information about the sides, but you knew some information about the angles. So let's say you knew like two of the angles are like 100 degrees and 20 degrees or something. And in the other triangle, there's also a 100-degree angle and a 20-degree angle. And let's say the side, one side has length 5 or something, and the other triangle also has a side of length 5. Then you can conclude that these two triangles are congruent by ASA congruence. And an interesting thing about ASA congruence is that it does not rely on the side being between the two angles. Like you can also have AAS. So back when we had SAS congruence, like it's important, like only SAS works. We cannot have like SSA. We can't have the angle not be between the two sides. But we're allowed to have, in ASA, we're allowed to have the side and not be between the two angles. So for example, if we had a triangle that looks like this, and let's say we knew it had a 100-degree angle and a 50-degree angle, and let's say the side was not like between the two angles. Let's say the side was like here, has length 10 or something, and you have another triangle that also has a 100-degree angle, a 50-degree angle, and a side of length 10. Even though like the 10 in this case is not like between the two angles, it's not like this side here. We can still conclude by AAS congruence that the two triangles are congruent. And the reason is because if you know two of the angles in the triangle, we know that the sum of the angles in a triangle is always 180 degrees. So if you know two of the angles, then you know that the third angle is like automatically fixed because the sum of the three angles must be the same. So essentially, if you have ASA congruence, you also have AAS congruence. They're basically the same thing. And the last type of congruence that we'll talk about is called HL congruence. And HL congruence is like specific towards right triangles. So HL congruence says if you have two right triangles, so if you have two right triangles or something like this, and they both have right angles, and I should say HL stands for hypotenuse leg. So notice there are no A's and no S's in here. So this is kind of like a new abbreviation. This stands for hypotenuse leg. And just in case for people don't know, the hypotenuse of a right triangle is just like the longest length of the triangle. It's like the length opposite the 90-degree angle. So HL congruence tells us that if we know that the hypotenuses of the two triangles, let's say we know both of them have length 10 or something, and we know that the two triangles share a common side length, a common leg. So maybe this common side length is 5. They both have a leg of length 5. Then we can know that these two triangles are congruent by HL congruence. And notice that like HL congruence is kind of like a special case of SSA, right? Like when we talked about SSA earlier, this is not like valid. The angle has to be between the two sides. Notice that the right angle is not between the two sides. So you can kind of think of HL as kind of like a special case of SSA that works. So note that HL congruence only works for right triangles. Yeah, so those are like the 4 main ways you can use to determine whether or not two triangles are congruent. So just to like summarize, like the first way was SSS congruence. If you know all 3 sides of the triangle are the same, then the two triangles are congruent. You also have SAS congruence. So if you know the two triangles have 2 sides in common and the angle between the 2 sides is equal, then you can conclude they're congruent. We have ASA and AAS congruence. So if you know 2 angles and 1 side, that's also sufficient. And the last one we talked about is like HL, hypotenuse leg. If you have 2 right triangles that have the same hypotenuse and they share the same leg, then we can also say they're congruent.